Hello guys, welcome back to Maison African Motives, still on mathematics and 5, working on our integration, whereby we have an introduction of the Laplace on our integration. There's a part that you're supposed to understand how to use the Laplace in our integrals. We are not talking about the whole chapter of Laplace. It's actually a broad topic, this one of Laplace transforms, as we are just focusing the only small part of integration, which is given in such a way that representing a Laplace, let's say we have got a Laplace of f of t in this case. This is our Laplace of a certain function of f of t. It can be written in terms of an integral, whereby this is equivalent to the integral of e to the exponent of minus st. Always when you are dealing with the Laplace, e to the exponent of minus st, where you are supposed to express your answer in terms of s. So like I said, we are not talking about the broad part of where this actually came from, which is the Laplace, all right? Then multiplied to the function of your t in this case, which is multiplied to your f of t with respect to t. So once we integrate this with our limits taken from 0 up to infinite, that is the equivalent of the Laplace of f of t. So this f of t that we are talking about, it can be, let's say, it's an exponential. It can be exponential. It can be a trig. Let's say it's sine of t. So meaning to say, if here there is sine of t, here we are going to have sine of t. It's an expression for t. It can be a normal term, just like a t, like algebraic, meaning to say here we are going to have t. If it is a number, this f of t, if it is representing a number, let's say it's 7, meaning to say here we are going to substitute a 7. That is the whole part of our Laplace. So as we can see, after we have converted our Laplace into the integral that we are seeing on the other hand here, which is into this integral, it means we are supposed to integrate and apply the limits part, apply the limits. We talked about this on a separate video about the use of limits in this case, which is a infinity limits, the application of infinity limits. That is the one that you're going to use. The only part that you're supposed to take note is this part, e to the exponent of minus st times f of t, whereby your f of t is the one that you're going to be given. All right, so meaning to say, if I am given, like for an example, let us give this part here. We are asked to calculate, you might be given a question like this, calculate the integral of a certain function that is e to the exponent of minus st like this times t like this with respect to t. Once we have this part of e to the exponent of minus st, that's a Laplace there. We are representing a Laplace. So already, meaning to say on our Laplace, if f of t that we're talking about is this t, this is the one that is representing our what? Our f of t. Remember, we're saying the Laplace of f of t is equal to, so that's our f of t, this one that we have. So with this part, whether you understand that it's your f of t does not matter. What matters is, can you integrate this part? Because the whole part is you just need to integrate. The application there of our Laplace is to integrate. So you need to integrate these two. So it's a product. So you're supposed to think of what? We're supposed to think of our by parts concept in this case, all right, whereby we know that from our by parts, we have the integral of f of x g prime x dx, which is equal to f of x by gx minus the integral of f prime x, that's gx dx. You're supposed to know this, but you're given in your formula sheet, so it's an advantage, whereby our f of x in this case is the part that we can actually differentiate. So we can choose to let this be our f of x. If you don't want to confuse, you can just rewrite this, because it's the same way. Infinity 0, you start with the t, then you end up with e to the exponent of minus st dt in this case, whereby this is your f of x, which is your f of t. We are no longer having f of x, we are now working with t. So this is where there's f, where there's x, you're just simply using what? You are simply putting a t in this case. So meaning to say, this is our f of t. As we can see from our f of t, which is t, we are going to need its derivative in this case. So what is going to be the derivative of f of t? That's a 1. All right. we do the same thing to find our GT in this case, which was supposed to be GX, but now it's GT. So that means it's taken from the remaining part, which is representing our G prime X dt, G prime T of dt, which is equivalent to e to the exponent of minus st dt. So in order for us to find GT, we integrate both sides. That's our GT is going to be the integral of e to the exponent of minus st. Remember, the integral of e, it remain as it is, e to the exponent of minus st. Then you find the derivative of this function, okay, which is the derivative of minus st, which is going to give us minus s. All right, so this is what you're supposed to have, of which you can take the negative up. All right, we shall talk about this. Let us put into this part. All right, whatever that you're going to get here is going to be taken as f of t, which is our f of t is t. So you're going to have t times gt, in this case, our gt, which is this part where we got e to the exponent of minus st over minus s, like this. So this is what we obtain, minus the integral of, so you're going to have the integral of f prime t in this case, which is our f prime, which is 1. So this is going to be 1 by gt in this case, which is this part as it is, e to the exponent of minus st over minus s, like this, with respect to t this time, because we are having this in terms of what? In terms of t. So we have to use t in this case. All right, with our limits infinity and 0. All right, once you are at this stage, you can simplify before we can integrate. This is same as t over 1. So if you multiply, this is going to be t times e, which is going to be t times e to the exponent of minus st over, this is 1 times negative s. So it was supposed to be negative s, like this. But we can take this negative up, all right? Instead, we can take the negative up. We remain with s in the denominator here. All right, the same thing here. We've got a negative and a negative. So this one is going to give us a positive, all right? We remain with the integral. This 1 can be taken outside with s. This is a constant, 1 over s. Remember, we've taken the negative out. We can also take 1 over s because s is representing a constant. So it is going to be 1 over s, the integral of what is remaining here, which is e to the exponent of minus st with respect to t. So as we can see, we are simply back to our normal integration that we are used to, the normal integration that we actually know in this case. So if we are to take now into consideration of what we are obtaining from this part, all right, let's check another part that I wanted to explain here. All right, if you are to take into consideration, before here, you could have simplified, okay, this part, you could have simplified this part, which is the one that we simplified here. All right, we could have even simplified to take e to the exponent of minus st down. In this case, you could have done that, simplify properly. But in this case, we are simply having one and the same thing, okay? So it's not a matter to worry about. All right, now at this stage, we are supposed to integrate what is left here. And also, if you take note, the integral of e to the exponent of minus st, we did it here, which is this one, the integral of e to the exponent of minus st with respect, that is the one that we got, this one that I was explaining about, to say we could have simplified, but let us just take as it is. So we are going to obtain minus t e to the exponent of minus st, like this, over s. All right, so this is going to be plus 1 over s times the answer that we are obtaining, which is e to the exponent of minus st from our integral over minus s. All right, so this is the whole part that you're going to obtain after integrating, not forgetting our limits. All right, since we are to apply the limits whereby there is an infinity in this case, it is best to have fractions in this case. If it is f of t over gt, let it be that way. All right, so that we can properly see if there is a condition which can give us infinity over infinity, so that we apply our L'Hospital's rule in this case. So if we are to simplify here, we can get rid, because this function, it consists of t. and it has a negative exponent. So you can take it down so that it will be minus t over this s, which is already in the denominator, that, but it's going to be e to the exponent of minus st like this. All right. So we do the same here. We simplify this part. We take it down because it carries a negative. But in the first place, let's deal with this negative and this positive. It gives us a negative. Then we take this one down. So it's going to be 1 over, already there's s times s here, which was going to give us s squared. If we take this e to the exponent of minus st down, it's going to be e to the exponent of minus st with a positive like this, e to the exponent of positive st, I mean. All right, so with this part that we have, now we can apply our limits. So the first part, remember, it is supposed to be the upper limit minus the lower limit in your substitution. In this case, what am I trying to say? We are supposed to substitute our upper limit first, we subtract the lower limit. So our upper limit being infinity in this case, all right? So if we substitute here, we are going to have infinity. Remember, e to the exponent of infinity, from that part of our introduction, I said it gives us infinity. So meaning to say here we are going to obtain infinity over infinity. Whenever there is infinity over infinity, you are supposed to apply the L'Hospital's rule. In that case, apply L'Hospital's rule. Remember our limits on the first place, guys. All right. So meaning to say our L'Hospital's rule state that we are supposed to find the derivative now. So we differentiate. You just apply it where there is infinity over infinity. That's where you apply it, or maybe it's 0 over 0. We talked about this. Okay. So here we are going to have the derivative of minus t, which is minus 1 over the derivative of e to the exponent of minus. Remember, when there's a derivative, you drop the exponent s. So it's going to be s times s, which is s squared, e to the exponent of st. Now we apply again our infinity part. So it is going to be minus 1 over infinity. This is s squared times e to the exponent of an infinity is going to give us infinity. So meaning to say, after applying our L'Hospital's rule, this whole part is going to give us minus 1 over infinity in this case. All right, minus, we move on here, we've got 1 over, we substitute here, there is going to be infinity. E to the exponent of infinity is going to be infinity, like I said. So this one is going to be 1 over infinity again. So this is our upper limit minus the lower limit. So we're going to do the same thing on our lower limit in this case. All right, so let us check, because we said it's upper limit minus what? Minus the lower limit. So on the lower limit, that's a 0. So we substitute a 0 here. So this one is a 0, this one is a 0. So we're going to have 0 over e to the exponent of a 0, that's a 1. But the moment we have got 0 over 1, we are going to obtain a 0 there. So that's a 0 minus, we substitute our lower limit, which is a 0 here. So in place of t, we are going to substitute a 0 in place of t, because it was with respect to t. So we're going to have e to the exponent of 0, which is 1. So we're going to have 1 over s squared, because s squared times 1 is going to remain like that. So you're going to have minus 1 over s squared like this. All right. Knowing that from our limits, we said k over infinity gives us a 0. So this one is going to be 0. This one is going to be a 0. So that's 0 minus 0, which is a 0 minus 0 minus 1 over s squared. We are going to obtain minus 1 over s squared. That's 0 minus minus, which is going to give us a positive 1 over s squared. Minus and minus, that's a positive. So our answer is going to remain, is going to be 1 over s squared in this case. That's how you apply the Laplace. That's the Laplace concept. The Laplace that you are simply having is this s that we are simply having, maintaining or working with this s, but the whole part, it's your integration. As you can see, there's nothing changed. We are still back on our normal integrals to say this Laplace of f of t is equal to e to the exponent of minus st times f of t. So you simply integrate and apply the limits as we saw from this part. So sometimes they might give us a question which is like, for an example, they might say calculate like this. All right, calculate the Laplace of, they might even state direct like this, calculate the Laplace of f of t, which is equal to 5. they gave us to say f of t is equal to 5. Calculate the Laplace of this if f of t is equal to 5. So if you actually know that it's a constant here, the answer is, I want you to see what is happening here. Our Laplace was 1 over s squared. Because here we are having e to the, it's not a, it's a t in this case. If you're dealing with a linear, we are going to have what? A constant over s squared. In this case, the constant that we are talking about is the number that is affecting your Laplace in this case. If you are dealing with a linear part like this, our answer is just going to be 5 over s, but we are supposed to prove it. We are supposed to work it out like this. Is like I want you to know where it was actually taken from so that we understand each other. Remember what I said about the Laplace? I said the Laplace of f of t, all right, the Laplace of f of t in this case is equivalent to the integral of e to the exponent of minus st times f of t in this case with respect to t. So we are given that our f of t is equal to 5. So meaning to say we are talking about the Laplace of 5, whereby f of t is going to be a 5. So this whole question that we are given, they are simply asking us to integrate, in this case, e to the exponent of minus st, whereby being multiplied by f of t, which is 5 with respect to t. So that's it. Once you are given this, guys, you are done. You integrate. This is the Laplace of 5. If it is the Laplace of sine t, if they say the Laplace of f of t is equal to sine t, you put here sine t, you integrate. If it is f of t is equal to 0, function of t, you multiply that, but here our f of t is 5. The function here, our f of t was t in this case. If you check on our previous question here, our f of t, this one, this same question was supposed to be, instead of asking this question to say calculate, they were supposed to say find or calculate the Laplace, find or calculate the Laplace of f of t is equal to t in this case, because that is what is representing our f of t, where you substitute now your f of t, e to the exponent of minus s. This one is constant throughout. It's not going to change. That's the Laplace. All right. So in this case, we are given our f of t, it's what? It's 5. So that's why we are substituting 5 in place of what? Our f of t here. Once you have got this, the rest, it's your integration techniques. So back from our integration, this is the same as the integral of, we can just change now. Now we know our expression. We can just change it to our favor, because it's us who is calculating this. We can change it to our favor so that we can properly integrate. Remember, the integral of e is going to be e to the exponent of that function of f of t over the first derivative of what? Of t, of the function, which is this part of minus st. So meaning to say, we are going to obtain 5e to the exponent of minus st as it is. We differentiate, we find the derivative of minus st, which is minus s. This one, we are not having a product like whereby there was a t and e to the exponent of minus st, whereby you apply whereby we now end up using our by parts concept. No, this one is direct. It's a 5, it's a constant. So just integrate, apply your limits. That's it. So let us see if we are to simplify here. We can take this down. Remember, a negative can be taken on top. So this is going to be negative 5 on top. We can take this negative on top like this. So it's going to be negative 5. All right. So we're going to have negative 5 over, we take this one, this is s, so this is 5, this is s. We take this e to the exponent of minus st down. Remember, now to remove a negative, it becomes a positive, e to the exponent of minus st. If you are given a condition of limits where there is infinite, try by all means put your function as a fraction, not to remain with negative exponents like that. All right. So the moment we substitute, our upper limit is infinite. So we're going to put infinite where there is e. Remember, I said e to the exponent of infinite. It's infinite. So we're going to have infinite times 0, which is simply infinite. So that's minus 5 over infinity like this. Minus, we substitute our lower limit, upper limit minus lower limit, or lower limit, that's S0. So if we substitute S0 in place of E here, E to the exponent of 0, that's a 1. So it's 1 times S, which is going to give us S in this case. But knowing that there's a minus 5 on top, so it's going to be minus 5 over S in this case. So this is going to be minus 5 over S. All right. This one, remember, a constant over infinity, that's a 0. A constant over infinity, it gives us a 0. So we are going to have, at the end, we are going to obtain a 0 minus minus, which is a plus. So that's plus 5 over S in this case. 0 plus 5 over S is simply going to give us 5 over S in this case. All right, so that was whole part of our application of the Laplace. That is how you use the Laplace. Laplace, there is nothing. They are simply saying integrate, apply your limits. So if you know, or if you have done that part of infinity limits, if you have watched the video of infinity limits, then this one is not going to be a major story, because the only part that you are simply now talking about is this st, e to the exponent of minus. This is the only part that changed, whereby the Laplace of f of t simply means e to the exponent of minus st times f of t, which is the one that you're given here. So if they give you a 5, you put a 5 here. If they give you a t, you put a t here. If they give you a cosine of t, you put a cosine of t. What is important is that you are supposed to integrate whatever that you're going to remain with here. Do you know how to integrate? If there is a function of t and a function of a t, you apply by parts. But if it is a constant like this one, f of t like this one is just a normal integral, like what we saw in this case. It's just a normal integral. We just integrate the same way that we are used to, but maintaining our s, because s is representing a constant. So you substitute the limits on t, not on s. T is the one that is affected. So I think that's it. Just have to work with more questions as you revise for your exams. Just have to work with more questions so that you prepare for the exams that are ahead of time.